Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman.
Hello.
I'm here with my fourth period class, and today is super exciting because today we learn algebra. Yay! Woo! All right. Whoa. A lot of kids get really nervous when they hear algebra. They think, oh no, I can't do this. This is difficult, right? I'm here to tell you that we're going to pretend like algebra is a big pool, right? And I am not going to throw you in the deep end. There are some kids swimming down there doing fancy dives off of the diving board. There are people, swimming underwater without their nose plugged. And yeah, you'll be there one day. Today, you are the little kid in your little bathing suit and your little floaties on your arms, okay? Your little life jacket. And you've got me going, come on, it's okay. So I want you to picture you're just kind of enjoying the shallow end of the pool right now. And we'll get down to the deep end as you get closer to 7th grade, when you're in 7th, 8th, high school. But right now we're just dipping our big toe to test the water and see what we can do. So our main goal today, we actually have two main goals. Our first goal is to practice expressing multiplication as addition and repeated addition as multiplication. All right, so that's kind of an old school skill that you already know. And then we're also going to learn something fancy, a fancy way to write multiplication in the land of algebra, which is coefficients. All right, so here we go. We're going to start by first, now just a little qualifier here. The kids do not have their module booklets yet, so we're going old school on this. We're going to take some notes by hand, which is not a bad thing. So first thing I need you to do in your module book right now is to draw 3 groups of 3, all right? Okay, so the first thing we're going to do is write this visual diagram as an addition expression. So who can tell me what addition problem is shown here? It's pretty simple. Don't hesitate. DeQuaila, nice and loud.
3 plus 3 plus 3.
Very good, but you're not going to believe this. I'm not going to make you write the answer because we're just practicing writing the expression, okay? Crazy, I know. All right, so 3 plus 3 plus 3 is how you would write this as an addition expression. Now, how would we write that same addition expression as a multiplication statement? Connor?
3 times 3.
Very good. We have 3 groups of 3. So 3 times 3. Now, notice I'm avoiding writing an x because now that we're dealing with algebra, we're going to use variables a lot, so we're going to shy away from using the x as multiplication, okay? So one thing I want you to think of is in terms of groups. So we have 3 groups of 3, right? So I want you to write under there 3 groups of 3. I have my methods. Please just trust me on this. All right, the second thing I need you to draw is 2 groups of 8. All right, so what would the addition expression be for this? Hunter?
8 plus 8.
Very good, 8 plus 8. Who can tell me, now let's think of how many groups of something. What would this be as a multiplication statement? So I want you to say how many groups of how many in each group. Jackson?
2 groups of 8.
Very good. So we would say 2 groups of 8 is 2 times 8. And I want you to write down 2 groups of 8. And the reason I want you to write 2 times 8 instead of 8 times 2 is because I'm gearing you up to then change the second number there to an algebraic variable, all right? So even though the commutative property of multiplication states that 2 times 8 is the same as 8 times 2, I want you to get into the habit of thinking how many groups of something else. And in algebra, the new language we're going to learn today, of means what operation do you think? Connor? Very good, multiplication. So that's kind of a clue word that we have. So All right, let's do this last one that we're going to have a visual example for. So draw 3 groups of 5. All right, I need an addition expression to go with this. Who can give me an addition expression? Bryson, go ahead.
5 plus 5 plus 5.
Very good. That is the addition expression. And who can tell me what that would be as a multiplication expression? Hunter.
3 times 5.
Very good. We have 3 groups of 5. 3 times 5. And let's write 3 groups of 5. All right, nicely done. Seems pretty easy now, but don't worry. We're in the pool of algebra. So we're not going to do exercise 1 because great job editing, New York State. It's the same example as C. So we're going to move on to the next page here, which is to write equivalent expressions to demonstrate the relationship of multiplication and addition. So if they give us addition, we're going to write it as multiplication, and if they give us multiplication, we're going to write it as addition. So 6 plus 6, we have how many groups of 6? 2. So we would write what multiplication statement, Cassie? Very good, 2 times 6. So again, try to just use the dot here. Do not use the X because we don't want to get that confused with a variable. All right, the next one, I want you to write this one down, 3 plus 3 plus 3 plus 3 plus 3 plus 3. So that means 3 being added together 6 times. So how many groups of what do we have? All right, think of it in terms of that. Someone I haven't heard from yet. Not everyone at once, I mean, geez. Jacob, you had your hand up on the last one. What about this one? How many groups of what?
3.
So how many groups of?
6.
So how would we write that as multiplication?
3 times 6.
Flip it.
Oh, 6 times 3.
Yep, because we have 6 groups of 3, so I'm going to write 6 times 3. And I know I'm being picky with that, but just trust me on it. It'll make the transition to algebra a little easier. Okay? All right, the next one, we have 4 plus 4 plus 4 plus 4 plus 4. So we have 4 being added together 5 times. So how many groups of 4 do we have, Connor?
5.
So what would our expression be?
5 times 4.
Beautiful, 5 times 4. All right, the next one, please write this down. We have 6 times 2. So 6 groups of 2. So how would I write that, Jaden?
2 plus 2 plus 2 plus 2 plus 2 plus 2.
Very good. So 6 times 2 is the same as saying 2 plus 2 plus 2 plus 2 plus 2 plus 2. All right. You can hear that smartboard rattling probably. All right, the next one. We have 4 times 6. We have 4 groups of 6. All right, so what would this be as an addition, repeated addition problem? Hunter?
4 plus 4 plus 4 plus 4 plus 4 plus 4.
Actually, that would be 4 groups of 6, so I want you to do it the other way. So write that second number.
Of 6 plus 6 plus 6 plus 6.
Perfect. All right, and then this next one, 3 times 9 is the same as saying 3 groups of 9. So how would we write that, Jose?
9 plus 9 plus 9.
Very good, 9 plus 9 plus 9. All right, now this is where it starts to get a little bit exciting, okay? We're in the algebra pool. We've got our little floaties on, and we're starting to splash around a bit because now instead of numbers, we're going to be seeing some letters. We call letters in algebra variables, okay? Because the value of those could vary depending on the problem. So I like to use this analogy. Anyone watching this video is probably like, this lady is whacked. But the way I like to describe it, it's kind of like a Halloween party or a masquerade ball, right? And the numbers sometimes get a little sick of just hanging out in their regular number outfit. And they're like, I want to dress up as an H today. And so their Halloween costume is just like and h. We don't know what number h is. We got to be okay with that. Like, oh, look at how many people dressed up. Look how many numbers dressed up like h, right? It's kind of cool. Sometimes in a problem they'll tell us what number h is disguised as, right? And sometimes they won't. We have to be comfortable sometimes leaving it as is, and then other times we will be asked to figure out what this expression's worth, or maybe if it's an equation we can actually figure out what h is worth. But in this case there's no way of telling. We can just simplify this down. Instead of saying h plus h plus h plus h plus h, we can use what we just did to figure out how we'd write that algebraically. Does anyone have an idea? Bryson, what do you think?
Is it 5H?
Whoa, did you learn this before?
No, I saw the one.
Very good, nice job. You put h and h together, really. All right, so he said 5h. Now, a lot of kids earlier said 5 times h, but you'll notice in algebra, multiplication gets super fancy. You don't see the x, you sometimes see the dot, but what the most advanced way is to write this is with what we call a coefficient. So if you want to draw a little arrow to that 5, we're going to call this a coefficient. All right, and notice it's always written in front of the variable. It comes first, okay? So that doesn't require any symbol there. If you see a number and a letter grouped right next to each other, that means they are being multiplied, okay? So we're going to look at this next one, part H. It says 6y. So who wants to expand that out? 6y. Let's turn it into an addition problem. Hunter.
Y plus Y plus Y plus Y plus Y plus Y.
Very good. Nice job. Sounds like a little kid, right? Why? Anyway, you guys have little siblings that ask why all the time?
No, I am.
You are the little sibling? Sure, Bryson.
I have a big sibling that does that.
Okay, well, maybe it's not age specific. I just thought little kids tend to ask why a lot. All right, anyway, so we are going to practice this some more. We're going to skip that page. We're going to go to this next one, exercise or example 5. Write an equivalent expression to demonstrate the relationship between addition and multiplication. So again, we're just going to simplify these into multiplication if we can. So 6 plus 6 plus 6 plus 6 plus 4 plus 4 plus 4. So write down what you need to there, guys. So who can tell me what we could do with the 6's? What could we do to write that as multiplication? Kyla, I haven't heard from you yet. What do you think? How many groups of 6 do you see there?
4.
All right, so you would write that as?
4 times 6.
Beautiful. 4 times 6 plus, how many groups of 4 do we have, Jose?
3.
So we would write 3 times 4. Now, obviously, we could use order of operations to then simplify this down and find the answer, but we're just practicing the converting from addition to multiplication. So now we're going to practice what if we had letters instead. So I want you to copy this one down. D plus D plus D plus W plus W plus W plus W plus W. So we have 3 D's being added together, which is being added to 5 W's all being added, okay? All right, so who can tell me how we would write this? How many D's do we have added together? Cassie? 3. So you would write that how?
3 times 3.
Not 3 times 3. 3 times D. 3D. So we don't need a dot. We don't need an X. We just write 3D. And again, we're writing lowercase variables unless we're dealing with something specific like area and whatnot. So, all right, so we have 3D plus, we also have what? Connor?
5W. 5W.
Very good, 5W. Now here is the question of the day. Can we combine the 3 D's and the 5 W's? What do you guys think? Nope. Unfortunately, we cannot. All right? That's a common mistake that a lot of 6th graders make. They think that they can combine everything. Now, in algebra, there's something called like terms and unlike terms. So this is a term and this is a term, right? And they're considered like terms if they have the same exact set of variables with it. All right? So if this over here was 5D, and we had 3D plus 5D, then we could combine it. But we know this is 3Ds plus 5Ws, so they cannot be combined, okay? They are unlike terms. You can only combine like terms. All right, why don't you guys try part C on your own right now? All right, Colby, what do you think it is?
2 times A plus 3 times B plus 4 times C.
Very good, and you can actually read it just like you wrote it. 2A plus 3B plus 4C. Nice job. Who had what Colby had? 2A plus 3B plus 4C. Who had that? Nicely done. All right, one thing I want to point out, notice that we don't list the C and the B before the A. When you're writing these different terms out like this, you're going to list them in order from, well, they're going to go alphabetically, the variables. Does that make sense? So it's kind of standard practice with that. So A's come before B's, come before C's when you're listing them out. Okay? All right, guys, so now we have your homework, which is actually the problem set. So I'm going to pause this. Unfortunately, since you guys don't have your module books, we're just going to copy these down, right? And your job will to take anything that is addition and change it to multiplication. I do not want you to say 10 plus 10 plus 10 equals 30. That is not the point here, okay? I want you to say 10 plus 10 plus 10 equals what times what, all right? And then you're going to do all of these. I'm going to give you a few bonus at the bottom. So just in case you forgot your homework or you're watching this because you have no idea what you missed, the first one is right there. Second, third, you can see all those. I'm going to scroll down now so that you can see the next set. 4, 5, and 6 are right there. And then you can always pause this if you need to. And then a few bonus. All right, I've got these 2 for bonus as well for a little extra credit. Alrighty, so thanks for watching Math with Mrs. Lehman. Don't forget to give it a thumbs up if you haven't already, and please subscribe. Have a great day.